Hello, my name's Doug Arion, and I'm the Executive Director of a public science education program called Mountains of Stars. I'd like to discuss here the use of astronomy as a way to do public science education, particularly associated with the environment. And one of the key ways to look at it is this cartoon, which says if people sat outside and looked at the stars each night, I bet that they'd live a lot differently. And if we can connect people with the big picture, I think they would live a lot differently. And I think it's something that we should be pursuing and should be a goal of the communication that we do with the public. Now, you can exemplify this sort of with this little diagram. If you talk to a lot of people, they would probably, if they were honest, give you a description that looks something like this, that there's a hierarchy, that humans are at the top of it, that all the resources of the planet and all the other life forms are, shall we say, below us. I really think, though, that if you take a cosmic view and you really understand this one history that built what we have, and the fact that there's a single picture and that everything is completely interleaved, you realize that there really isn't a hierarchy, that it's a completely flat association of everything that is here. Now, we who do astronomy are in an incredibly unique position, because astronomy, after all, is the study of everything in the universe, and everything in the universe includes everything that's here, of course. And it also has the aspect of being thoroughly awe-inspiring to audiences. So we can leverage that inspiration to bring across messages and connect with them in ways that traditional other kinds of science communication can't do. Now, the program we run, Mountains of Stars, our goal here is what we call environmental understanding from a cosmic perspective. And there are a number of key features of our program, one of which is that we are partnered with one of the leading conservation organizations in the country. We've done programs for over 65,000 people in the 9 years we've been operating. And we make a special effort to train outdoor guides, nature educators, and undergraduate science students in science communication and this particular curriculum that we're doing here. And on this image, you can see a few of the programs and activities we do and one of the student teams that we worked with before COVID kind of demolished our programs last year. So what do we mean about these kinds of things and these messages, and how do we do them? All of us are used to bringing current science to people, whether it's just the pretty pictures of things, whether it's doing an observing program, whether it's communicating the most current science results, whether it's something about the cosmic background radiation or imaging a black hole. We are mostly just giving them information and telling them things. But what is the point? What does it mean to them to get that information? And most importantly, how can we use this opportunity to change their behavior? How can we change the way people treat the environment and view science by having them engage in public astronomy activities? So I'd like to give you a couple of connections, a couple of the kinds of things that we have found to be very effective in doing this. So, for example, one of the things that we often talk about with people is stellar nucleosynthesis, although we wouldn't use those terms, and where all the elements come from. But what's really unique and appropriate about this is that if you then look at the preponderance of elements throughout the universe, lo and behold, two of the very most common are carbon and oxygen, which leads to the fact that if you have carbon, oxygen, and the primordial hydrogen, lo and behold, you have the building of sugars. Now, sugars are very important because they're the basis for every kind of life on the planet. So all of organic chemistry is derived from what actually happens in stars. And of course, that chemistry is completely universal. It's not just humans, it's every living thing. Everything here either eats it or makes it. Similarly, the next most common elements that are made are magnesium, silicon, and iron, and of course, combined with oxygen, form all the minerals on the planet. So again, the fundamental things that make all of the components that make up Earth, all of the life that's here, is derived from stellar processes. Similarly, you can talk about the creation of the atmosphere from the productions of sugars, the need for water, why that's common for all of the life forms here. And that if you look at, well, the Milky Way at night here or external galaxies, you see that these processes are going on absolutely everywhere. So trying to think about us as being unique and more important than anything else is really a misnomer if you take this kind of viewpoint. We frequently tell the story of this continuous recycling of materials and enhancing by supernovas and planetary nebulae and so on, and the production of elemental abundances, which of course have led to us being here. But one of the most important things to get across is not only did that lead to us, but it also led to all of the other living things on this planet, because the chemistry is common to all of them, and all of them are the result of this complex collection of activities that have gone on. And you can look at these balances of factors. On the one side, on the left here, you can see all the things that you would think that would make life very common. And on the right, you would find those things that had to happen to make humans appear, which includes all the extinctions that had to occur, the creation of all the different kinds of animals, and plants, bacteria, everything that's here is the result of the same collection of processes. And that means all of it is equally valuable and probably equally unique throughout the universe. If you get this kind of messaging across to people, we can start addressing, through astronomy, using astronomy content, lots and lots of different issues that are here that we can get people to think about, whether it's climate change, food production, water, species extinction, the available of natural resources, the pollution that we generate, energy opportunities, and of course light pollution, but talking about it as an environmental issue, not just as an astronomy issue. All of these are tied into these same processes. All of them can be discussed in terms of astronomy. And we can look for people to take actions. We can have them look at the products they buy. We can have them look at the kinds of foods that they purchase and transport. We can look at the kind of plantings that are done. You know, grass, for example, is not a good natural environment where wildflowers are. We can show them about bad lighting and not just what it does in terms of losing the stars, but what it does in terms of safety and health and the environment. We can motivate them to think about how they vote, and we can ask them to communicate all of this to their friends, because we need large groups of people to be solving these problems. Now, some of the other activities that we do, we spend a lot of time talking about light pollution. We have the advantage of working with a conservation organization to be partnering with the IDA to protect a large region of what's now northern Maine. That's that very dark area you see to the upper right in the United States as an international dark sky park. That is one of the major steps that we can use to not only protect an area, but to engage more of the public. We make all of these resources available, and I urge you to take advantage of our website. On it, we have a whole area that's available to the public. It's a way to continue engagement with them, where we have collections of videos and books and interviews and materials that they can follow with. If you get the login to our site, and we'll be happy to share that with anybody who's doing public science programs, we also have a password-protected area where we provide a lot of original resources and background materials that you can use to bring this message to the public. One of the things that we have found extremely useful are a number of books. They're all referenced on the site. I would highly recommend, if you're interested in this topic at all, to begin with Langmuir and Brooker's How to Build a Habitable Planet, which really connects all the processes on Earth that begin literally with the Big Bang and coming to present day, and covering all of these interactions and connections. It is really a very, very useful resource there. There are many partners who've been part of our program. I put their logos up here. We've been funded by a couple of sources, but one of our major advantages has been partnering with a variety of academic institutions where we're able to engage with faculty and students. And I will leave you with our Facebook page, the website address, and my personal email that you can use to contact me at any time. Thank you.